myself Maninder Kaur, lecturer chemistry. Today my topic is different types of chemical bondings. The covalent bond model. Linus Pauling received the Nobel Prize in Chemistry in 1954 for his work on the nature of the chemical bond. What is chemical bonding? A chemical bond is an attraction between atoms or molecules. A chemical bond is the attraction caused by electromagnetic force between opposing charges, either between electrons and nuclei, or as the result of a dipole attraction. The strength of bonds varies considerably. There are strong bonds such as covalent or ionic bonds and weak bonds such as dipole-dipole interactions, the London dispersion force and hydrogen bonding. So, chemical bond is an attraction between atoms or molecules. Since opposite charges attract via a simple electromagnetic force, the negatively charged electrons orbiting the nucleus and positively charged protons in the nucleus attract each other. The negatively charged electrons orbiting the nucleus and positively charged protons in the nucleus attract each other. Also, an electron positioned between two nuclei will be attracted to both of them. Thus, the most stable configuration of nuclei and electron is one in which the electrons spend more time between nuclei than anywhere else in space. These electrons cause the nuclei to be attracted to each other, and this attraction results in the bond. Types of bonding. First is ionic bonding, Lewis structures and covalent bonding. Structures are three types: resonance structures, octet rule and polar molecules. Why atoms combine? First is chemical formula, second chemical bond, and third is stability. First of all, we will discuss the chemical formula. It shows first elements in the compound, second ratio of their atoms. For example, water. This is first is oxygen, one oxygen and two hydrogen atoms. Chemical bond, strong attractive force between atoms or ions in a molecule or compound formed by transferring electrons or gaining. Second, sharing, formed by transferring of electron or sharing of electrons. Stability, octet rule. Most atoms form bonds in order to have 8 valence electrons. Full outer energy level like the noble gases. For example, neon, it has 8 valence electrons. Stability is the driving force behind bond formation. All noble gases except helium has an S2p6 configuration. Octet rule: atoms tend to gain, lose or share electrons until they are surrounded by 8 valence electrons. Octet rule: atoms tend to gain, lose or share electrons so as to have 8 electrons. Carbon, its atomic number is 6, 4 valence electrons. Carbon would like to gain 4 electrons, and nitrogen, its atomic number is 7. It would like to, its valence electrons are 1, 2, 3, 4. It would like to gain 3 electron, and in oxygen it would like to gain 2 electron. Valence electrons are 6. Electron distribution in molecules. Electron distribution is depicted with Lewis electron dot structures. This is how you decide how many atoms will bond covalently. In ionic bonds, it was decided with charges. Bond and lone pairs. Valence electrons are distributed as shared or bond pairs. Valence electrons are distributed as shared pair or lone pair. These are shared pair or lone pair, and unshared or lone pairs. These are lone pairs. These electrons, they do not take part in bond formation, they are called lone pairs. So this is a Lewis structure. Bond formation. A bond can result for an overlap of atomic orbitals on neighboring atoms. Overlap of hydrogen and chlorine atom. Exception to octet rule: central atoms having less than an octet. Relatively rare. Molecules with less than an octet are typical for compounds of group 1A, 2A and 3rd A. Most typical example is BF3. Formal charges indicate that Lewis structure with an incomplete octet is more important than the ones with double bonds. Central atoms having more than an atom. This is the largest class of exceptions. Atoms from the 3rd period onwards can accommodate more than an octet. Beyond the 3rd period, the d orbitals are low enough in energy to participate in bonding and accept the extra electron density. Bonding. Lewis dot structures show the valence electrons. These are valence in nitrogen 4, 5. 1, 2, 3, 4, 5. 5 valence electrons. Electron dot structures show the valence electrons around at atom, and for most molecules and compounds a complete octet for the elements. Most monoatomic ions have an electron configuration of noble gases. Symbols of atoms with dots to represent the valence electrons. Hydrogen have 1 valence electron, lithium 1, sodium 1, helium 2. Drawing Lewis structures. Follow step-by-step methods. First, total all valence electrons. Second point, write the symbol for the atoms and guess skeleton structure. Third point, place a pair of electron in each bond. Complete the octet of surrounding atoms. Place leftover electrons in pairs on the central atom. If there are not enough electrons to give the central atom an octet, look for multiple bonds by transferring electrons until each atom has 8 electrons around it. Chemical bond is a attractive force holding two or more atoms together. Covalent bond results from sharing electrons between atoms, usually found between nonmetals. Ionic bond results from the transfer of electron from a metal to nonmetal. Metallic bond is an attractive force holding pure metals together. Bonding in ionic solids. According to ionic electrostatic model, solids such as sodium chloride consists of positive and negative ions. Positive and negative ions arranged in a crystal lattice. Each ion is attracted to neighboring ion of opposite charge and is repelled by ions of like charge. This combination of attraction and repulsion acting in all directions causes the ion to be tightly fixed in its own location in the crystal lattice. Ionic bonding. What is ionic bond? It is a electrostatic force of attraction which holds the oppositely charged ions together. For example, sodium ion and chloride ion. This is the formation of ionic bond in sodium chloride. The atomic number of sodium is 11 and it has one valence electron. The atomic number of chlorine is 17 and it has 7 valence electrons. Sodium is donating 1 electron to chlorine and chlorine atom it is accepting that electron and the bond formed between them is called ionic bond. So, ionic bond is formed by the transferring of electron from one atom to another. Look here, the electron from sodium moves over to Cl. Sodium becomes sodium ion, it is called a cation, and Cl atom it becomes chloride ion, it is called an anion. The positive and negative charges attract each other, form an bond. It is called ionic bond. Another picture. Electron from sodium is transferred to chlorine atom. This causes a charge imbalance in each atom. The sodium becomes sodium ion and Cl becomes Cl negatively charged particles or chloride ions. Ionic bond between atoms of metal and non-metal with very different electronegativity. Second point, it is formed by the transfer of electrons. Produce charged ions, all states, conductors and have high melting point. Example, sodium chloride, calcium chloride. Electrovalency. It is a measurement of the net electric charge of an ion and is used when balancing chemical reactions. Electrovalency is related to the concept of electronegativity and valence electrons. It is related to the concept of electronegativity and valence electrons and indicates the number of electrons necessary for an ion to have a balanced electric charge. Electrovalency. Atoms that have an almost full or almost empty valence shells tend to be very reactive. Atoms that are strongly electronegative, for example, halogens, often only have one or two missing electrons in their valence shell and frequently bond with other molecules or gain electrons to form anions. Silver ion, ferric ion, cyanide ion. When an ion only contains a single atom, it is called monoatomic ion, and when it contains more than one atom, it is called a polyatomic ion. Conditions which favor the formation of ionic bond. First is low ionization energy. Now, what is ionization energy? It is the amount of energy which is required to remove the most loosely bound electron from isolated gaseous atom to form a positive ion. Ionization energy, it is the energy which is required to remove the most loosely bound electron from neutral gaseous atom. In forming an ionic bond, one atom must form a cation by losing one or more electron. In general, elements having low ionization energies have a more favorable chance to form a cation and thereby having a greater tendency to form ionic bond. Second is high electron affinity. Electron affinity is the amount of energy released when an isolated gaseous atom accepts an electron to form a negative ion. Electron affinity is the amount of energy released when an isolated gaseous atom accepts an electron to form a negative ion. The other atom participating in the formation of ionic compound must form an anion by gaining an electron. High electron affinity favors the formation of an anion. Therefore, generally the elements with higher electron affinity favor the formation of ionic bond. Halogens have high electron affinities and therefore halogens generally form ionic compounds. Large lattice energy. When a cation and anion come closer to each other, when a cation and anion come closer to each other, they get attracted to each other due to Coulombic force of attraction. These electrostatic forces of attraction between the oppositely charged ions release a certain amount of energy and an ionic bond is formed. Properties of ionic compounds generally have high melting point, usually solid crystals. They can conduct electricity when melted or dissolved in water. Covalent bond. What is a covalent bond? A covalent bond is a form of chemical bonding that is characterized by sharing. If you see this picture, they are sharing their electrons. Sharing of pairs of electron between atoms and other covalent bonds. The stable balance of attractive and repulsive forces between atoms when they share electron is known as covalent bonding. Covalent bonding includes many kinds of interactions including sigma bonding and pi bonding. So, Covalent bonds, they are formed by the sharing of electrons between atoms. Examples of covalent bonding in water: hydrogen, cis, oxygen, two hydrogen atoms, and they are sharing the electrons. So the bond formed is covalent bond. Covalent bonding in methane: carbon, hydrogen, CH4. They are sharing four hydrogen atoms and they are sharing the electrons between atoms. Nitrogen. Look here, they are sharing their electrons. Covalent bonding in hydrogen: H atom, another H2 molecule, they are sharing the electrons and the covalent bond is formed. Oxygen molecule, two atoms share one or more pair of outer shell electrons. Covalent bond between non-metallic elements of similar electronegativity. They are formed by sharing electron pairs. Stable non-ionizing particles, they are not conductors at any state. For example, oxygen, carbon dioxide, H2O. What are the characteristics of covalent compound? First is low melting and boiling points. The melting and boiling points of covalent bonds are generally low. This is because the forces between the molecules are weak and thus are easily overcome at low temperatures. Second is solubility. Covalent compounds are generally insoluble or less soluble in water and in other polar solvents. They are, however, soluble in non-polar solvents such as benzene, carbon tetrachloride, CCl4. State of existence. The covalent compounds do not exist as ions. Covalent compounds, they do not exist as ions but exist as molecules. They are weak intermolecular. There are weak intermolecular forces between the molecules and hence they exist as liquids or gases at room temperature. A few compounds also exist in solid state, for example, urea and sugar. Non-conductors. Since covalent compounds do not give ions in solution, they are poor conductors of electricity in the fused or dissolved state. Double bonds. Oxygen can't remove two electrons from another oxygen atom, so they share. Two pairs forming double bond. Similarly, in case of nitrogen, it can't remove 3 electrons from another nitrogen, so they share 3 pairs forming triple bond. Two non-metal atoms form a covalent bond because they